also be time conscious today so we can be able to have time for questions and answers. And we also plead that instead of interfering while he's presenting, we note down our questions. At the appropriate time, we will table those questions for clarifications. All right, thank you, and enjoy the session.
Thank you. Um, Good morning once again. My name is Onen Dennis Oyaro. Yesterday we started our session with introduction, and we did we did installing ARA and ARA Studio. Then also we did some installation of packages. Then we did some cleaning, data cleaning, and also brief analysis or qualitative data. Today we'll start from overview of what we did yesterday, so that can remind people who might have forgotten, and those who might have not been around yesterday. So I will not go through the installation of ARA and ARA Studio, but I'll go straight to the overview of setting the working directory and importing the data. Then I will follow through up to where we stopped yesterday. Then we continue to today's session. Are you seeing my screen?
Yes, I can see it.
So yesterday we said if you have already installed ARA and ARA Studio, you don't need to. You just need to click on you double click on the ARA Studio icon, and it will open. It will open for you the windows for ARA Studio, because ARA Studio cannot run without ARA. So after opening your ARA Studio, we have 4 windows. We have the script window, we have the global environment, the plots or the chart window, then we have the console. So as we said yesterday, it is best to first set the working directory or to the folder where you will put all your information. So we go through session. I don't know if you're saying my ARA Studio.
Yes, we're seeing it.
Eh?
Yes, we are seeing.
Okay. So we said to set the working directory, you go to session, then you go to set working directory and choose directory. Then it will take you to your computer, and you select from your computer where your folder is. For my case, my folder is on the desktop, and this is the folder. Then I open it. Then after setting the working directory, you can come and import your data. So you can import the data in SPSS format, SAS, text-based, or CSV, and also Excel. So you could come here using this option, or if you have already set the working directory, you come just to File. It will open your directory and show you it will show you the file which are inside the folders you are working on. So these are the files I'm having, and this is the Excel sheet I was working on. I was working with. But since we had already copied our 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 commands for setting the working directory and pasted in the script window, and also the command for importing the data from the console yesterday. What we just need to do, we just need to run. Just need to run. We need to load our packages because we'll use them later on. So this is setting working directory, loading the data. If we are to view the data, oops, let me first remove this. So if we want to check the column names, we use col names. If we want to check the headings, then we use the heads, then the name of our data. If we want to do know the structure of the data, we use the function str and the name of our data. So if we want to use our data for analysis, but we don't want to keep typing the names of the name of the data and using $sign to select the column, then we attach the data. This one is showing, it is showing that the following objects were masked from training data. So this one means that I already attached the data sometimes back. So if I didn't want this one to show, I would have detached the data. If I detach the data, I'll have to detach until when I see error. It means that why? I've attached the data several times. So it looks like I've attached the data like 5 times. So I have to detach it 5 times. But if I attach it again, you'll, oh, there's some data which I've attached, which I need to remove. But this one doesn't affect. It will not affect the what? It will not affect our analysis. So we looked at the relationship between sex and smoking status. And we did we created what? We created the contingency table. So for us to create the contingency table, we use this function, table. So table is an inbuilt function. So if you install ARA, it automatically comes with ARA. So you don't need to install package for it, for what? For reading it or for creating it. So if we want to view the contingency table we have created, we use the function view. Then it will show for us in an arrow in the format of table. But if we want to see it down in the console, then we don't need, we just copy the name and paste it down and we run it. It will bring for us down. If we want to test the relationship, whether it is significant or not significant, since we are dealing with the qualitative variables, we use the chi-square test. So from the chi-square test, we have the degree of freedom, the p-value, and the x squared. The R p-value shows that there is a very strong association which is significant between the status of smoking and the sex. So we could also use the table we have created to generate a data frame which we will use for what? For further analysis, like plotting graphs and other. So it is better we convert our thing into proportion, either percentage or there's normal proportion from 0 to 1, ranging from 0 to 1. But if we convert to percentage, then we'll have to multiply by 100. That's why we have the 100 here, but we are rounding to how many decimal? 1. So if we are to view our table, realize we have the sex of the participants and the what? The smoking status. Those who have stopped smoking, those who have never smoked, and the smokers. We could view this table using the function view. Then we type table 1. Not this upper one, but the downer one, because this table 1 comes automatically when you install some of the packages. So we need to go to the table we have created, which is table 1 with capital T. Then it will bring for us. It is the same, but on that how the factors are arranged. Are we together? Oh, I'm too fast.
We are together.
Pardon?
Sorry,
We are
Mr.
together.
Dennis, to take you behind. You began by saying when you are starting the other section, you need to install the packages or to load the packages rather. Could it mean that once the session is done, the packages are automatically removed from the other section you were using?
Okay. Let me go to that section. Once you have already installed the packages, you don't need to reinstall them. You just need to load them. Now,
Okay.
if you were working on ARA and you have loaded, let me say this packages here, but you have not closed the ARA, you can just go continue using the packages. But if you close the ARA, then you will need to reload the packages afresh.
So when loading, you are using a library command.
Yes, you have to use the library command for loading the packages because you have already installed.
Okay, all right.
This command here, install.packages, is used when you don't have the packages. You need to, when you have installed your ARA but you have not installed any package, then you'll use the install.packages. So after installing the packages, you just need to load them using the library function. If I'm to reinstall these packages, let me say ggpattern or ggplot or any of these packages, since I've already installed them, I'll have to, it will tell me to restart ARA or reinstall to what? It will tell me that you have already installed these packages. Do you want to reinstall them? Then it is your choice to reinstall them or not. But it is not necessary to reinstall these packages when you have already installed them.
We can move on now. It's fine. I've made myself understand.
Okay. So if we also looked at the relationship between cardiogenic shock and the diagnosis. So we created the contingency table using the function table, and we gave it the name. We assigned it the name, Descartes.shock. So when we run this, it will create for us the contingency table. If we run this one alone, the Descartes shock, the one we have assigned the name, it will bring for us those with the cardiogenic shock, and those without cardiogenic shock, and those with the shock. Then you see other diagnosis. There are those with non-STEMI and those with STEMI, then unstable angina. If you are to do to test for the relationship using the chi-square test, we'll see that there's a significant relationship. So we could use this data, to generate a proportion table. And this proportion table, we are taking it to 100 because it is easier to deal with percentage. Sometimes, okay, to me, it is easier to deal with percentage, but it depends on what you want. So from the first table that we created, for the relationship between the sex and the status of smoking, we created a data frame. So we convert that table to a data frame by just using the function as a data frame. Then we put the name of our table. Then we use that table to draw the graph using the function, the GG, using the GG what? Using the GG plot too. I had not yet loaded this one. I had not run this command. That's why the GG plot had refused. So this was the graph we created, looking at the status, the smoking status, the ex-smokers, those who have never smoked, and those who are still smoking. Then male and the female being compared. So this is the graph we got. For the GG plot, what you need to know, you just need to know the name of your data. If you are importing a data frame, you just need to know the name of your data, then your X and the Y. Then this other part here, this other part, they will just come naturally. Okay, you may just need to, if you get the command, you just change this, you change this one and change this one. This is the Y axis, this is the X. So you just change this, if this does major thing. Then from here, coming downward, coming up to here, you can just copy and paste, it will come. But the important part is to correctly put this information, the name of your data frame, the X-axis, and the Y. Then these other values which are in the table also, you just need to change them according to your data frame, to the information in your data frame. Then we also look at the relationship between smoking and obesity. When we did the chi-square test, we created the contingency table and we computed the chi-square test. So we observed that there was no significant difference. There's no significant association between smoking and obesity. When we look at the proportion of the different people, well, this is the table. But this one you may not put in the report, the results for reporting, because there was no significant difference. You can just put the highest value and the lowest, much as there was no significant difference. We also look at the association between smoking and the cardiogenic shock. So when we did the association test, there was no significant association, given that the p-value is 0.445. We also look at the association between obesity and the cardiogenic shock. When we did the analysis, there was a significant association. The p-value is less than 0.05. Actual p-value is 0.0135. So that one shows that there was a significant association. When you look at that table, just by the exact numbers, we see that among the people who were not obese, 524 did not have cardiogenic shock, and 43 were having cardiogenic shock. And the people who were obese, 281 never had the cardiogenic shock. Meanwhile, 9 had. So when you present these results like this, someone may not be able to okay, people will see the difference in terms of the value, but what of the percentage in terms of proportion? You may decide to present this one by combining both these results, so the numbers and the proportion. So when we did the proportion, this is what we get. So that marks the end of day 1. Can we proceed to day 2, or we may need to understand something? Any question from day 1?
Good morning. Good morning once again.
Good morning.
Yes, I still have a lot of questions. Sorry. We have checked for some association and for some differences. So my concern is that suppose we found that there was a difference. Could it be there's a way of finding the actual difference, or you just report that there is a difference in was it mean comparison?
I've not got you well.
The last test for chi-square, where we are checking for the last test that we were checking for, we are checking for the differences. We are checking for the difference where we concluded that there was no significant difference. Now, in a case whereby there is a significant difference, do you state the actual difference, or maybe you just report that there is a significant difference?
Oh, now with chi-square, we are looking at the association. How are they related? Is there a relationship or no relationship? So when we look for this case here, we have p-value of 0.014. So it shows that there's a relationship, but there might be relationship, but there might not be. There might be relationship, but the relationship may be significant or insignificant. So for our case here, the p-value is less than 0.05. That's why we conclude that there was a significant relationship, or there's a significant association between obesity and cardiogenic shock. So we can conclude that the obesity, because we don't have much information. Because we have only cardiogenic shock and obesity. But basing on the proportion, you may realize that those who are not obese and were not having cardiogenic shock were 92%, which is a very big proportion. Additionally, those who were obese and had no cardiogenic shock were 96.9, which is also a big proportion. So we can just say there is a relationship between obesity and cardiogenic shock. And that relationship is significant. So maybe if you want to put in writing, you say there's a significant relationship or there's a significant association between obesity and cardiogenic shock. Then you put the p-value of 0.014. Then you can start bringing in this information.
Okay, thank you so much. Yes, we're together.
Okay.
You can proceed.
So should we go to day 2?
Yes, I think we can go to day 2 if the participants have no other question.
Yeah, so let's proceed to day 2. Yeah, for day 2, we are still going to use that. You want us to do some descriptive statistic, the mean, the standard deviation, the variance. So if you want to do, for instance, we are using the data, the same data we have used yesterday. So I want us to do descriptive statistics for that data. So we have if we use summary, the function summary, and we put the name of our data, it will give us the descriptive statistics for the entire data. So after running data command, it realized it started from row names. Then it came to age. Now, when you look at the age, the minimum is 28. The first quartile is 55. Median is 64. Mean 63.31. Upper quartile is 72. Then maximum. This is the minimum, maximum. For sex, it is stated that sex is the character. So the number which appears most is also character. Then the cardiogenic shock, still the same character. So we could what we could do, if we want to get the descriptive statistic for each, let me first get the column's name again for our data. So we have the H, the earth activities. We have the sex, the height. So we could do the descriptive statistic for each and every column. So we can just say summary if we want to use for H. Then we put H. It will bring for us minimum, first quartile, median, mean, upper quartile, and maximum. If we want to do for BMI, we can still do BMI. It will give us the same thing. If you want to do the mean, you just want the mean, then you can do mean, BMI. For instance, if we put for the BMI, it will, BMI has some missing gaps, I think. So if we remove the NS, those are the what? The missing values. The missing value you can remove using this function, NA dot remove. RM is remove. When you look at the BMI, like this one here, if you are using the other function, it can bring for you error. If we are to do for TC, LDC, LC, it will it may bring for us error. So to avoid those error, we can use this na.remove to remove those error, to remove the na. Then you say true. But if you put F, capital F, it means you cannot the missing value should not be removed. So it will still bring us error. So if we want, we can still do descriptive statistics. Anyway, you can do any descriptive statistics. We can do the standard deviation. The standard deviation, you just use SD. It will bring for you the standard deviation. But what if we are told to do what? To calculate the standard deviation, the mean, the variance for the different what? For the different, let me say, variables. Then we have to, we can use the function. Now this is where we need the. This is where we need the package called what? Tidyverse. This package is the one which can be, which is used for this kind of grouping and others, and other manipulation of the tables. But since we have loaded, there's no need for us to what? To load it again. So here I'm saying, let me create a new data. You can say day 2. Then I put the name of my data, which I had imported. Then from that data, I'll use this. It's called the piping sign. It is just use the. You can use a shortcut of Control, Shift, then you press M. It will bring for you this automatically. But if you cannot, then you can use you can do it in a normal way. Percentage sign, the greater sign, then percentage. It will still be okay. So after putting that by piping, then you say group by. So if I want to group by the column of obesity, now after grouping, what do I want? I want to summarize from that data, from this data, create the data called data day 2. In the data you're creating day 2, pick from this data and group using the column called obesity. Then summarize. Now, when when you're summarizing, I'm creating this is create a column called average age, and from that column, we are going to get the mean of the age, and after removing the missing values. Then I also create the standard deviation of the age using the function HD, using the data from the column age while removing the missing values. Then at the same time, create the average, the column called average body mass index or BMI using the function mean and the value for BMI, but removing the missing value. Then also the standard deviation. So we could do for all the other what? All the other variables. Then when we run that command and say check, we view our day 2. This is what we are going to have. We have the people who are obese, the obesity status, those who are not obese. The average age is 64.7. The standard deviation is 11.67. The average BMI is 22.29, and the standard deviation for BMI is 1.987 or 988. But I can decide to group using, this one may not be necessary if you are what? If you are grouping with only one category. But what if I want to group with what? If I want to group with two categories, for instance, let us first look at the data. If we look at the training data, we have the entry, we also have the diagnosis, then we also have the smoking status. So what if we want to group with the obesity status and the smoking? So we just come and say smoking here. Then this one becomes important because now if you remove the groups, it will only group using the first factor, but the second one will be left out. So if you want to keep it, if you want to keep the second category also, then use keeps. After running the command, here is what we get. We have the obesity status, the smoking status, the average age, the standard deviation, average BMI, the standard deviation. We could actually do the variance. Well, this one is actually important when you want to do another stage of analysis. For instance, if you want to draw the graph and you are told to put the standard deviation for the graphs, then you need to put this for your standard deviation or the standard errors. We could actually add the variance. You can say H. We create a new heading called H dot variance. Then we put var. Then we use the value for H, the information from the H column that we remove the missing values. It automatically adds the variance. So if you want to get the standard deviation, the variance, and others for all these quantitative variables, we can do by just adding. We can just keep adding to this group. But if you want to group with other thing, add another group. For instance, if we are to add another group, the diagnosis, then we just come and add here. Then it will change. Are we together?
Yes, we are through.
Okay. Yeah, so it's, in some cases, you are told to draw the graphs, but before you do, when you're drawing, let me say the bar graphs, they may need the standard errors or the error bars. That is where you may need to know. You may need to use this. That's how these commands become important. So I think for that part of descriptive statistic, I think we can stop there. Then we go to another part, which normally people don't always do. They normally do very few and they leave out, which is the Yeah, we call it for the ANOVA. Before any analysis of variances that is done, we need to do some testing. So we have the main assumptions for ANOVA. We have that the data should be normally distributed. Then the second one, that the observations should be independent across the different groups. Then also, one of the most important is that the variances or the variance should be homogeneous. So for us to test those one, we have several tests. We have the Levin's test. Now the Levin's test tests for homogeneity of the variance. Meanwhile, the Shapiro test, the test for normality. Then also, Anderson-Darling test also tests for normality. Now the difference between Shapiro and Anderson test, Shapiro tests for sample less than 5,000. 5,000, we test for those one with less than 5,000 observation. If you have more than 5,000 observation, you'll need to use another test. So you can use Anderson-Darling test, which is just edit or test. Then determining the independence, you can just do the residual plot. So let us use the data we are having. So for instance, we are using, if we are to do if we have to use the data we are using, the one we have shared yesterday, let us do the test for which variable should we test? We have the EF, we have the plant, we have the height, we have the weight, we have the BMI. So this one normal test for those quantitative variables. So which one should we choose?
You can do height.
Okay. So if you have to do the height for Levin's test, now one important thing when you're dealing with the Levin's test, this is our variable, this is a factor. So so let me generate a model. Let me use LT for Levin's test. Then I say 8 tilde we can use either diagnosis or entry or obesity status or smoking. So let me use smoking. So if we have to do Levin's test, we use this one down, then put in our function there. So this is the result of our Levin's test. The p-value is 0.0046. So this one shows that our variance is not equal. because the assumption is that for living states, the assumption is that the variance is equal. So that is the null hypothesis. But the alternative hypothesis that assumes that our variance are unequal. So when the p-value was greater than 0.05, we would fail to reject the null hypothesis and say the variance are equal. But since the p-value is less than 0.05, we can conclude that our variance are not equal. So, so this one has already failed. It has already failed an assumption, one assumption. Also, one thing which we should notice, if you're dealing with when you want to do Leibniz test, this one should be like a factor. So if you have things like the edge, you may need to create the edge group and convert it to factor. Then you can do the analysis. And also this should be a factor which is the representative of all the factors you will use in the analysis. Then the next test is Shapiro test, which is for normality also, which is testing for normality. So let me can remove this. Leibniz test, let me put the comments because I know I'm going to share this. The Shapiro test for normality. So with Shapiro test, it's simple. Just write Shapiro dot test. Then you put the name of your variable. For instance, for this case, we are using height. So our data is not normally distributed. If you use Shapiro test, the p-value is very low. We would have used histogram. So this is how it looks. But this one is skewed. If we have to draw the distribution line. So this is our histogram. But the formal test is normally the Shapiro test, though you could use histogram to tell you the same thing. But the Shapiro test will give you the p-value. So let us create a model. Let me say height then we can use A of V command or A of V function. Then we say height varying with we can say diagnosis, obesity, and smoking. The X then we can plot this. So this is the residual plot. Is there any pattern? So this is the residual plot, which is used for testing for the independence. There are several plots which will come after this. There's QQ plot.
Maybe Onen, you can just make us understand the residual plots, how to interpret it. Yeah, thank you.
Oops. That's when my arrow is a bit freezing. Well, when we are looking at the residual plots, these points should be randomly distributed. They should not follow any specific patterns. My arrow is freezing. Give me a minute. Sorry, people, I have to restart my arrow. It's taking long. Are you seeing my screen?
Yes.
Okay, thank you. So when you're looking at the residual versus the fitted plots, these points should be randomly distributed. They should not follow any specific patterns. And also, this one tell us whether they are outliers. So you see this point here, this point, and those are outliers. So the ideal would be this one following the 0 points. But when you see the red line, it is a bit deviating. But when we look from the QQ plot, the ideal would be to follow this straight line here. So these points here may require transformation, data transformation. So the data points are not independent. There's some specific relationship. I don't know if you got it. So for us, we are supposed to base on the straight line. Then it also shows the outliers. So this point, those are the outliers. So that is testing for independence. And this is the same. There's some kind of negative slope. So the ideal would be straight, horizontal. So this one is the residual plot is actually used for testing for the independence. So when we are doing those assumptions of ANOVA, it is important that before doing any analysis of variance, it's important we do the testing for these different assumptions. Otherwise, you may end up getting wrong results. Well, some people may not understand that if your paper or your thesis lands in the hands of someone who knows, who is a serious biometrician, can cause you some problems. Yeah. So for this data, for this I data, since it has not followed the assumption, we could do data transformation, or we could do other analysis. Analysis we have the GLM. Then we have linear mixed model. But it depends. So it depends on what you're working with, and okay, depends on what you're working with. If you're dealing with the, for example, for the entomologists, if you're dealing with the count data, your data may never obey any assumption. And also transforming the data may not change anything. It may actually bring you more issues. It may distort the data completely. So that is with transformation. But also, you can do regression. So these linear models, they are more of like regressions. They are more of like regression. When it comes to data transformation, we have the square root transformation, we have the log transformation, they have the arc-sine transformation. So I don't know if I should go into transformation. Should I go into transformation, or we do the modeling?
I think you should make the choice that best. I say you make the choice that best suits us, whether the modeling or the transformation, because asking the question, we find it difficult to respond. So which one best suits our program for today? Be good.
Okay. Maybe even before going going there. For instance, if I told you, like if your data is already, if you have already written your model like this, if you have written your model, let me say like this, and your thing has obeyed the assumption. So from here, that would be the easiest way. So you just get summary. If your if your data has obeyed the assuming all the assumptions of the ANOVA are obeyed. This one is normally common for the people who do experiment, because with experiment, there is some kind of control. So most time the assumptions are, sometimes the assumptions are obeyed, sometimes they are not. So if the assumptions are obeyed, from here you just proceed direct to your what? To your ANOVA. Then if the assumptions are not obeyed, then I'm coming there. Then you start to with when the assumptions are obeyed. Then what you do, you just need to write the function ANOVA. And you put your what? Your model. This is how it will be. Your ANOVA. That is if the assumption are obeyed. But if they are not obeyed, you are not supposed to go to to the ANOVA. And also, after like for those significant, for those factors which are significant, you could go and do other. You can proceed and do another analysis. Other analysis. You can do the multiple comparison. You could do multiple comparison. Then we say comparing the smoking status. But with the multiple comparison, you need this one here, with this function here. Okay, this is LSD test. You need to put this into bracket. So this one, it will give you the comparison. So you realize the smokers are actually taller than the ex-smokers and and those who have never smoked. But these are just I'm just assuming. But for the case of interaction, then you may need to what? You may need to use. You may need to create. You need to combine. Then this is how your LSD test will come. You have the people who smoke, the aid that is not significant from non-smoker. These are the people who smoke, but they are obese. But their height is not different from the people who don't who smoke, but they are not obese. That's also looking at the ex-smokers who are obese. Their height is not different from the ex-smokers who who are not obese. Those who are obese versus those who are not obese. So the height is not very different. But when you look at the smokers, the height is significantly different from ex-smokers. And those who have never smoked, the height is also not significantly different from those who have never smoked, but they're obese. The height is not significantly from those who have never smoked and they are not obese, which is similar to these results here. So if someone wants to determine interaction, you could use this, use the sign, the star. When we look at the ANOVA, here we see there's no interaction. So let us start with the linear model. Anyway, this is also a linear model, much as we are using the AOV command. It is a linear model because now we are saying height is a function of diagnosis, smoking, and obesity. So it is more of a linear model. We would do the same thing, but instead of using AOV, we use what? LM. So if you say height, it will still be the same thing. It will still be the same results. Here we had used AOV, the AOV. But down here we had used linear model. So it is the same thing. So for those who those who are having experiments, let me say the breeders, and they want to see the interactions. Let me say, for instance, the genotype by environment. Then you'll have to use the genotype. Sometimes it depends on the experiment you're dealing with. If you're having the RCBD, you may have RCBD, you may be having the alpha lattice, you may be having the Latin square. So it depends on the experiment you're doing. But for the general, this is how you do it. That is if the assumptions are obeyed. What you could also do, instead of using the ANOVA command, you just use summary. Now, this one will give you something else. This one will give you something else. This one will give you like a regression. So you realize that the intercept is significantly different from 0 with the p-value of this. That is the p-value. Then also, the diagnosis, when you look at those with the STEMI, there's a negative association, but negative relationship, but there's no significant difference. When you look at the smoking, there's a negative relationship. So that negative relationship is significant. So this is the coefficient. This is the p-value show for which indicates whether the data change or the coefficient is significant. So this is like this is a regression. This is more of regression. So if we use the plus sign, since we have seen that there's no interaction, can just use then we have it simplified like this. So the intercept is significantly different from 0. The STEMI, for a unit change in STEMI, the height increased by 1.54, but it is not significant. Meanwhile, for smoking, a unit change in smoking, okay, it is the change in smoking results into decrease. Oh, this is never smoking. For change in smoking, for those who don't smoke, changing smoking status, there's a significant change in the height. When you move from smoking to non-smoking, there's a significant change in height. So this is the regression model. I think I may need to use more of experimental or some big data. So let me, yesterday we installed a package called HH. You remember this package?
Yes, we do.
Hello? You remember the package? So there are several data in this package. So let us use the data in HH. So if you want to get the data in HH, you just need to type data and the name of the data, which is in HH. There's a book for statistics. It has very many questions it has very many information. All the data which were used in that book are from the package HH, and it includes both many experiments. So if you import the data, HH, HPRA, this is economic data. It's more for economics. I don't know if we have some economists in this room. So this is the data. We have the price, we have taxes, bathroom, lot size, the square feet of the houses, the garage, the rooms, the number of rooms, number of bedrooms, age and type of the house, then the style, and whether the house is having fireplace or not. So if we attach the data, let us first see the structure of the data. So price is an integer. So this data is a data frame with the price as integer, taxes as integer, number of rooms as numerical, the lot size, the square feet, those are integers, the garage, all those are integers. So What can we look for in this data? Well, we can do some regression and say this function is inbuilt in ARA. The moment you download ARA, you automatically have it. It is called pairs. So you just put the name, the function pairs, the name of your data, then from that data, from which column? So this is row. Then from which column? After selecting all the columns, then you select this. You write this is one. Then you run. So this is how the data looks like. When you look at the association between the price and tax, there's some kind of association. But when you look at the association between price and the bathroom, it is not very clear. But when you look at the price and age, it is also not very clear. But when you look at the price and lot size, it is a bit, there are some two values up here. So this might be the outliers or may not be outliers. So when we run that, so when we generate our linear model and we get the summary, this is what we get. So the cost, we say the cost, there's a significant, the intercept, this is the value for intercept, but it is not significantly different from 0. So the how do they call it? The coefficient of the tax is 0.1158, but it is not significant. So how do we interpret this? We say for unit increase in tax, the cost increased by this value, and for unit increase in the size of the bathroom or in the number of the bathroom, the cost also increased. But looking at the p value, the cost is not significant. But when we look at the square feet, for unit increase in the size of the house, the cost increased significantly by this amount. And this is the p-value. How many people are familiar with the stepwise regression? Are there people who have ever done stepwise regression? Oh.
Yeah, I think most people have probably heard about it, but I've not used it. So I suggest we have hands on it.
Now, with the stepwise regression, you have your model. For instance, this we say the cost, we gave the name of our model as cost. Then we say price is a factor of tax, the number of bathroom, the lot size, the square feet, the garage, the rooms, bedrooms, age, and fireplace. So when we do the summary, it will give us the what? This is the regression coefficients and the p-value with the estimated standard error and t-values. So if you want to do stepwise regression, with stepwise regression, it gets for us the best equation or the best model which explain the price or explain our variable. And it's very simple. If you have already generated your model, you just write step, then the name of your model. So we had 1, 2, 3, 4, 5, 6, 7, 8. We had 9 factors. But after doing the stepwise regression, we are having 1, 2, 3, 4, 5. So it is selected the best factors that explain the price or explain our variables. So when you do the stepwise regression, it is programmed in just a way that the computer will do step-by-step analysis, selecting and comparing which factor has more impact on our variable. Then they compare all the other formulas, then it comes out with only one equation. This is the same as this normal, how do they call it, linear model, y equals to mx plus c. So if we say our y is the price, then this is our intercept, the c. So we say price is a factor of tax, bathroom, square feet, age of the building, and fireplace with the intercept this. So when we do the regression model, this is what we get. So of all the other factors, the function generated that we have, the price is determined by this 5. 1, 2, 3, 4, 5. So the other remaining 4 were dropped because they were not much affecting the price. So if we have to report this, we would say price, after doing all the analysis, we would say price is affected, or price is a function of tax, bathroom, square feet, age, and fireplace. So for a unit increase in tax, or for a unit increase in tax, the price increased by 0.139. And for a unit increase in the number of bathroom, the price of the house increased by 77.988. The same applied for unit increase in the, let me see, the unit increase in the age of the house, the price dropped by 0.84. Then increase in the fireplace, the price increased. Then another important thing is when we are doing the regression, we need to look at whether there is association between our variables or our predictors. So if we are if there's, much as we are looking at the price, if there's association between the lot size and taxes, then our results may actually be affected. That's why we have to use what? Variance inflation factor to determine the variance inflation factor. So the variance inflation factor will tell us whether there is a association between our predictors. So it is easier to determine. You just write VIF and you put the what? You put the name of your model. Then it will show you the variance inflation factor for all. For tax is 7.8. Now there's a range. When there's no association between among the predictors, it will be 1. The VIF will be 1 for that factor. But for our case here, we are having 7 for the taxes, 8 for the bathroom, 2 for lot size. The square feet is 9. So for the room is 11 and bedroom is 10. There's a possibility that there is association between this bathroom, rooms, and bedrooms. So this one would require what? Any variance inflation factor of less than 10 of more than 10 is too big. So it might require combining some of these predictors which may be associated. Because if you look at the square feet, there should be some association between the square feet and the room size, and the rooms, and the number of rooms, or the room size, and also the bedrooms. So if there is association, then the variance inflation factor will be big. So between 2 to 5, it is moderate, but above 5 or more than or 10, between 2 to 5 is moderate. Above 5 and beyond 10 is too big. So normally, if they are too big, some of these things are combined. Some of those factors, those predictors which are associated with each other, are combined. So when we plotted this is the scatter plot matrix. When we plotted this scatter plot, we have some kind of outliers here. Those are some extremely big values. So remember when we plotted the residual and the fitted values. Now this is where you see there's no independence. When you look at our line is supposed to be from 0 lines, but when you look at these points, we have like outliers at 3 points, 6, 20, and 25. So here I tried to remove the outliers by filtering. So this filtering, I'm using the function tidyverse, the package tidyverse. So these functions is from the package tidyverse. So if you remove the outliers, sorry for that. So if we remove the outliers and do the printing, this way you may see some sensible results. When you look at the price and the tax, there is a positive association. But when you look at price and the bathroom, there's no association. When you look at price and lot size, a bit positive. When you look at tax and anyway, how to read this thing here, you look at the intersection. for the regression matrix, the scatter plot matrix, you look at the intersection where the one factor or one predictor and another predictor are meeting. So here, the price and taxes. Here, the price and taxes. But when you come down here, this tax and bathroom. When you come down, it is bathroom and lot size. So if we do the same analysis, we need to do the same analysis, but with the new data and see if there's any variation.
Yes, Donna. Yes, we have 10 more minutes. So I don't know how we can go with that.
Oh. So I'm trying to do this same analysis, but after removing the outliers, the higher values. So now, when you remember after when we have not removed the outliers, the intercept was not significant. Let me look for the data. It is here. The intercept was not significant. So after removing the outliers, this one has become significant. Then this one also changed. So when you remove the outliers, the data is much affected, because with outliers, there are outliers which can be influential, but there are outliers which may not be influential. So outliers which are influential, removing them will change the results. Those ones which are not influential, if you remove them, it may not change your results much. Now we have even very little time. So if we do it has not changed this one much, but compared to the previous one, it has changed a bit. When you look at the line moving, it has changed a bit after removing, but still, removing has brought in these values which were initially not there. So that one might require removing. So removing again might change the data. That's why sometimes if you remove the outliers, you may distort the data, and you might be, they normally advise you use another approach. When you zoom this, you see this one have become very clear, these points, and this one here. So that's why sometimes we are told not to what? Not to transform the data. Transforming data may not change it. Sometimes we are just told to split the data so that you do separate analysis. However, sometimes we are told to use linear mixed model or generalized linear model. But currently, nowadays, people recommend the use of linear mixed model. And now the linear mixed model requires you to know your data very well. If you don't know your data, it might affect the results. So this is the first thing we generated. Compared to the last one, this one here. Oops. So when we look at the stepwise regression, oops, not good. When you look at the stepwise regression, there are values which have changed. Initially, in our stepwise regression, we had H. When we have not removed the the larger values of above 800. So now bedroom has become a negative factor here. When we do the VIF, all the VIF reduced. So this one can tell you how the outliers can affect the data, and removing them can affect the data. If you leave it, it can affect the results. But if you remove them, it may also affect the result. So we need to know how to deal with the outliers. So this might bring us to the point where you may choose to remain with the outliers if you are sure the value was there, or if the value is accurate. But if the value is not accurate, or the outlier is outstanding and influential, then you may need to what? You may need to use another approach. So in most cases, the linear mixed model is the approach to handle those kind of data with a lot of the data which don't obey the assumption of the ANOVA. I think we may need to get time maybe in future, and we do only graphs. We do graphs, a lot of graphs, and also do into details of those models. We need to do linear mixed model, the generalized linear model, much as most people recommend this linear mixed model. But for the people who are having data of breeding, since we don't have time, you can do there's what is called bioflow. I don't know if anyone has heard of it. Has anyone heard of bioflow? You can just type yes or no. With bioflow, I think let us end the R here. With bioflow, let me just go briefly into bioflow so that you may one time, if you don't have time to learn from this site, you just need to just import your data. You import your data and do some analysis. It does the mainly analysis for breeding. Oh, someone has raised hands. Yes, sir, you can speak. Hello?
Hello.
Yes, I saw Dr. Hassan is up. Then this doctor?
Yes.
Yes.
Yes, it's Dr. Han. So are you done with the
Okay, good
presentation? I had
morning.
to.
Yes, sorry. I didn't know you called me. Thank you very much for the training. It's been very inspiring, eye-opening, and it's well detailed. A lot of practical things to do even after this training. But I just wanted to refer to the two regression that we ran, the stepwise regression and the normal multiple linear regression. I saw that in a stepwise regression, you don't have the level of significance or standard error or probability attached to it, so that you can know the level of significance of those variables. So I wanted to know whether uh, how is that possible to decipher, or is it a standard, or is it assumed as 5% or 1% or 10% of the significance? The other request is that some of the codes, is it possible to put comments so that you know that if you want to run stepwise regression, this is just as you did earlier. If you can just
Oh,
put some comments, maybe before sending them, so that we know which command is used for which type of analysis. Thank you.
yes, thank you, doctor. Let me start with the comments. Regarding the comments, that one I can add the comments for all those comments so that it is easier to follow. Then with the stepwise regression, mm, you asked for the what?
For
Now,
the
oh,
level of significance or standard error attached to the coefficients.
oh, now with the stepwise regression, important part, what they take as important is the AIC. They take normally the AIC, but the coefficient, it is because the commands is the design in just a way that it picks if you start from adding or in the reduction format, let us take for instance this command here. Are you saying my cursor?
No, we
Can
can.
see your
You're not
screen
sharing your
again.
screen.
You're not
Yes.
sharing.
So when you're doing stepwise regression,
We can't see your screen, please. It
You
seems
oh,
share
you
your.
stopped sharing. Yeah.
you're seeing my screen now?
Yes.
Yeah. Yes.
Yes, with the stepwise regression, why they rarely give the significance level and the coefficient is because if you are doing a stepwise regression in a descending order, it will pick like for this equation, it will analyze the entire equation the way it is, and it will give you the values, other values like the AIC, this, the RSS, the sum of squares, degree of freedom. But the next stage, it will remove this last one and perform the analysis with this. So when the second step is done, it will perform analysis with this one here. Then again, it will remove and perform analysis in a descending order until when it reaches only these two. Then the comparison will be comparing this analysis, the results when the AIC when you are having the whole of these predictors. Then when you remove one predictor like that until when you have like one predictor, then it will give you the best equation or the best function. So the best function now tells you that if I'm to consider, let me say manufacture. making house for sale. What do I need so that I have higher price? You know the tax is there. So do I need to, if I increase the number of bedroom, it will, the price of the house will go up by a given amount. Like for this case, it will go by this. So it had done the analysis using all this. Like here, it had done using 1, 2, 3, 4, 5, 6. Here, it had 6 factors. Here it had 1, 2, 3, 4, 5, 6. So here there are 6. So it kept doing analysis with fewer and fewer factors until when it can generate for you the best equation. And this equation, by the time you reach this level here, by the time you reach this level, it means these coefficients, the coefficients of H is actually significantly contributing to your variable. That's why it doesn't give you the p-values. What they take as importance are this one here, the AIC.
I think maybe most people will know the meaning of AIC is critical information criteria, right?
Yes.
Okay, not everybody has statistics background, so
Oh,
just
sorry.
wanted to know what's AIC, so they don't think it's a political party.
Sorry. Yeah, so this is step-based regression. And it's actually very good, like for people who want to make decision in business. Sometimes if you get your results, let me say you're making your, let me say the spores for sale, you're producing fungus spores for sale, mushrooms. You have your taxes, you have the flour you're buying, you have the house, the cost of the house, and other materials. Then you can align them like this and do the analysis. Then it will bring for you what is the best combination you can use to maximize your profit. Now this one is for economists.
Yeah. And just a supplementation on what you have already presented.
Mm.
You can just display the VIFs for the other first output where you had not yet removed the outliers, if you still have it.
We have not removed the outliers.
On the results section, on the results panel.
Yes, the VIF. Yeah.
Yeah, maybe also to just supplement on that output, the way Doctor was trying to inquire about the significant levels and everything. Now, this command in R, you can do this analysis still in R in a stepwise format. You can do the way the instructor said. You can keep removing one predictor at a time from the equation the linear model has built. Because why sometimes people are doing the regression analysis is because they have numerous predictors, and you want to come up with the most important predictors to that response variable you actually want to comment about. And it's a very good analysis, especially in the field of economics. Yeah, the best fit in the field of economics, because sometimes you're in a position whereby you have to make a decision, and probably that decision is going to maybe it is a policy. A government wants to pass out a policy, and they want to find out what are going to be the most important predictors. So that's why sometimes the linear regression comes in. And then the command which the instructor is actually running, you find that this command has been built to do those multiple regressions from behind the scenes. You may not see them, but it will give you the final output that this is what we may call the line of best fit. Apart, maybe if we have like 10 predictors, it has done the analysis and it has actually realized that 4 or 5 predictors are the best predictors in explaining what you're actually seeing as the response variable. For example, we are looking at the price. So on that specific, on his screen where you're seeing the VIF, what he has highlighted, you realize that we have about 1, 2, 3, 4, 5, 6, 7, 8, 9. We have about 9 predictors, but it's not that all these predictors are contributing to what we are seeing in the final prices. And these VIFs are actually showing us that some of them are actually related, they're associated. So you find that in our model, if you want to come up with a model, you find that what the square feet would explain in that model, even rooms can explain that. What the rooms can explain in that model, even the bedroom size can explain that. So this command was generated in a way that it will now pick out from the square feet, which has about a VIF of 9.9, and then rooms of 11.83, and then bedroom from 10, maybe 10.008. So it will see these as predictors, but these predictors can actually explain the same thing in this model. So it will just take into action, and it says, okay, these 3 predictors are in this model, but in our final model, I don't think we need all these predictors. We only take 1 because they explain the same thing in our model. So it picks out 1, the most fit predictor, and it picks out what we call the square fit. That's why in our that upper section, you can highlight it. That upper section, you're only seeing we have taxes, bathrooms, square feet, age, and fireplace. Because it has picked out square feet as the best predictor, and what square feet is explaining in that model, it is what actually the rooms and bedrooms would also explain. So that is basically the importance of regression analysis. Thank you so much.
Thank you, Chan. So this one might not be much applicable to people involved in experiment, but maybe if we have some time in future, we can put sessions mainly for the people involved in experiment, and also we may need to get time in future and do some serious graphics. Because 2 hours in a day, you cannot cover much. So that one remains to the admin of the association to decide. Thank you.
All right. Thank you very much, sir.
Yeah, yes, maybe I should quickly just ask this question for the benefit of all. I want to know what is the difference between summary and summarize? I know I used to use summarize, but again, I now know that you can also use summary. Maybe you can just demonstrate quickly the difference between summary and summarize in the code. Thank you.
Thank you, Doctor. I'd also not use this this summarize. So I think when you use when you're using summary, it is working well with the LM, but if you use summarize, it is not coming. So let me see if what I'm thinking is actually going to work. Wow. Doctor,
I know, yes, please. I know summary is for to summarize the descriptive statistics, so which is close to summary, but not essentially. That's why I wanted us to look at that. But another person has raised a friend. Maybe hand. Maybe you want to contribute to it. Femi, you want to say something?
No, I'm not contributing to this. I wanted to ask a question, a separate question.
You
Okay,
can
you
ask
can
the
ask.
question. Maybe it can be taken together. Thank you.
Okay, doctor, let me try to explain this. If you to remember, I tried using summarize. Remember here, I was using summarize, but here it is saying it is not applicable. Summarize is not applicable for the what? For the class AOVOLM commands. So I think maybe it can work best with the tidyverse and other packages.
Yeah,
But
I think so. I think so too, because here you are summarizing descriptive statistics. So that's what I want to differentiate, that you are trying to find the descriptive statistics to use summarize, but summary is for another. Yes, thank you.
okay, thank you.
Right.
Well, someone have the question?
Yes, please, quickly. My question is as regards you. How do you export your? Can you hear me?
Yes, I'm getting you.
Yes. When you do your graph or your scatter plot, for instance, how do you export it for us to put on Microsoft Word?
We'll come to you.
Exporting the graphs.
Sorry, we'll come to you. Olafemi, we'll come to you. We'll come to you. We've taken note your.
So this is how you export the graph. You just come to export. You can copy, you can save as PDF, or you can save as image. So normally for me, I use the dimension of the width of 1,200, then 700 or 650. It will bring. Since we have created remember when we were creating the working directory. So our working directory is what? Is in C. So the graph will automatically go to C. But in this, it will go to this folder. So I can say plot 1. So you'll take it as image, as an image. Is that one clear?
Yes, thank you.
Welcome, thank you. So other questions? If there's no question, then maybe I show you something brief for the breeders.
Sorry, good day.
Yes, please.
Yeah, sorry, I read late. So I want to ask if you did the dendrogram statistical plot for this training.
Pardon?
I'm asking if you did dendrogram statistical plot. So R has a function for dendrogram. I don't know if that was done or not.
Yes, R can do dendrogram.
So I don't know if you could just do it, because those are critical statistical plots that are useful for us who are into remote sensing and maybe climate modeling of sorts. So that's just just a thought. Anyway, thank you.
Hey, you want to draw dendrogram in R?
Please come again.
The last part I have not heard you.
Okay, so I was saying that some of us who are into maybe PhD modeling of data, so those are critical tools that are used. So that is just a thought on that, sir.
Yes. There's you can use R for modeling, by the way. because it is a programming language, so you can use it up to, yeah, there's a lot of modeling nowadays being done in R, even in Python. But since R is a free software and easy to learn, most of the work are being done in R. Even some part of GIS work can be done in R. Even analysis for those who do breeding, there's this thing of the genetic analysis, the QTLs and others, it's done in R. So you can do a lot in R. You just need the right packages.
Okay, thank you.
Yes, welcome. Any question?
Yeah, it seems you wanted to show us on the CGIAR Bioflow or
Yes.
something. Yes.
Yes, I don't know if there are people who have heard about Bioflow. Bioflow is mainly used in analysis of breeding data. Yeah, it also has ARA. If you want to download it, it has ARA. It's a bit heavy. It is around something 1 point something GB or even 2 GB. But you just need to import your data. You go to the website. This website here. And from that website, when you successfully enter the home page, then you go to what? Retrieve data. Then you can upload the data. So the data can be in any form. It can be in any format. So, but most cases you need the data in what? CSV. So when you, let me say, if you bring in this data, the upload will be complete. Then from there, you just need to what? To match the. You need to match the columns, but this data here doesn't have the what? Doesn't have much the important columns which are for this, because I don't have the breeding data. But for this pipeline, what you need, the location. For instance, if you are doing multi-location trial, you have to put the location. You have to put, if you are dealing with the genotypes, you put the genotypes here. Then the traits you're dealing with. Then you can proceed. So if you finish all this, it will take you to the quality check. After doing the quality check, then the phenotypic quality check, you do the genotypic quality check. Then you can go ahead and start analysis. You can do single trait trial analysis, multi-trial analysis. You can do met optimization and selection index or indices. So when you're most time when you're dealing with the CGL center or the CIMIT people, they normally use this bioflow for analysis. And it has actually all these packages we are using. All these packages are there, including some packages which requires license. They have it in that website. So if you feel like you don't need to write commands, yeah, this website is already having the commands which are written. You just bring in your data, fill in the required position, then run the analysis. You'll get the output in forms of the graphs, and some part are even interpreted. You can, if you want to learn more, you can go to YouTube. They have also tutorials on the YouTube. I happen to attend some training. That's when they explain to us the thing. But it's not difficult. Very easy. You just need like 30 minutes to learn everything if you have the data. Thank you.
I'm on testing for the website. I just copy a bit.
Hey, the website, eh? Let me just copy and paste in the chat. It is there. So I think I have to hand over back to the admin. Thank you.
All right. Probably, I don't know if Dr. Chupo is around. She had a question to ask. So I don't know if she's still on. All right. Yeah, okay, doctor. Over to you.
You referring to me because there are many doctors in the room.
No, I thought of Dr. Chupo. She had a question to ask. So I think she's responded that she's in there. So Dr. Chupo, is it? All right, if she's not maybe having a challenge, so Brian had his hand up. Mr. Brian had his hand up, so I don't know if he's ready for his question. All right. So probably, I don't know if someone else has a question that didn't indicate earlier. So we could take that one. Okay, maybe silence means yeah, oh, okay, except someone has something to say. We wish to thank the presenter, and we are so grateful for the time and the commitment to having us go through this session. As he said, as time goes on, we are going to see how to call you for more details or a deeper lesson on graphs, so we could better relate them with what we've learned today. Just to note that the group will be on. We won't close the group since we have more webinars to come that will tackle different issues regarding academic and professional lives. So we won't close the group at different points in time. Once we are ready with the webinars, we'll notify you. Before we give the floor to Dr. Wale for the closing remark and appreciation, I personally would like to appreciate all those who took our time to be able to sit in for this session. So, Dr. Wale, don't know, we'll be happy to get the closing remark and appreciation from you. Thank you very much.
Yeah, thank you very much, my dear Fumble, for facilitating the webinar. It's been very inspiring. This is the first time I was reflecting earlier this morning. I said this is the first Alumni Association ESCO that will be organizing a webinar in this manner. We've had different ESCO in the past, but this is the most formidable for now, and they are coordinated. So I want to thank your executive for doing this, for not just for your alumni association members, but also for the current cohort, as well as people who are not even part of the family, so to speak, the AGMCP family. So well done for this. I want, on that note, also, I want to continue to appreciate the facilitator uh, for these last 2 days. It's been very hectic. You are putting almost 5 hours of training without remuneration. I mean, this can only be a sense of ownership and sacrifice to develop other people. You know something and you're trying to impart on others. So it's highly commendable. So on behalf of all of us, we say thank you. So just a bit of also to the participant for sacrificing your time and your data, maybe to learn something, maybe Nobel or new or a sort of improvement to your own career. We want to tell you that the Africa Graduate Mentorship and Coaching Program is open to everybody between the age of 20 and 30 years in the continent. We normally announce call for application around October 1 to October 30. So if you are within the age group, look out for the announcement in October. For those who have participated in this training, we would like to issue certificates, but the certificate will not just go for everybody. We're going to develop a sort of a quiz just to test your understanding, and thereafter we'll give you a certificate of achievement. We'll be working with the executive and the facilitator to develop just multiple choice questions just to test whether you have really participated in these 2 days. Whether you get the certificate or not will depend on your success rate. So, but you should not be scared that it should be a simple test that will qualify. So at the end of the day, you can post on LinkedIn that you have achieved something, right? So we don't just want to give certificate for free. We want it to be, because at AGMCP and Images One Initiative, we are people of integrity. So we like to encourage best practice that we see around the world. So that's our own form of best practice, that if you have gone through a training, there should be a sort of test to say that you have achieved something. That said, I want to thank you again for joining and look forward to future webinars. As also, we'll send you the link to the test. If you succeed, then we issue you the certificate. Enjoy the rest of the day. Bye.
All right, thank you, Doctor, and to everyone.